hydrogen atoms, right, and one oxygen atom in this compound. Same is the case with NaCl, right? It contains one sodium and one chlorine. What about 2SO4? It is basically formula that shows the ratio between atoms of each in a compound. Common number, least common multiple is, for example, we divide this by 2, the answer will become, is it clear?
Yes, sir.
Or the internet connection? All right. So, what should be its empirical formula? Anyone?
The simplified formula.
What? What
The
should be the
sim
what formula of this one? See what? Please let me know. Tell me what should be its empirical formula.
सर ये सेम ही नहीं होगा C12 plus
Yes, excellent. The empirical formula will be same. Why? Because we cannot divide all these numbers by a common number, right? For example, if you're going to divide this by 6, or for example this by 2 or some other number, then we cannot divide this odd number. If you're going to divide this by 11 and this by 11, then you cannot divide 12 by 11, right? Last example, then we will be going. For example,
सर से
yes,
डिवाइड
please.
करना होता है कॉमन रेशियो से करना होता है
Common number से divide करना होता है. You'll have to divide it by common number. So, what should be its empirical formula? Divide this by which number?
9.
And this also by 9. So this will be CH2, right? Empirical formula can be same for two different compounds. So that's why you will identify a compound by its molecular formula, not empirical formula. Remember that. Every compound has different molecular formula, but they can have same empirical formula. All right, what about this? This is the molecular formula as well as the empirical formula. This is the molecular formula as well as empirical formula. For example, you can divide 2 by 2 and 4 by 2, but you cannot divide this 1 by 2. So if one of the elements present in a compound is indivisible by a common number, so you will not have to divide it, right? So generally, ionic compound, the formula unit are having empirical formulas, right? For example, if we are going to make bond between Mg and O, we know that valency of Mg is 2, that is plus 2. Valency of O is also 2, that is minus 2. So by cross multiplication method, you will find that for 2 magnesium we need 2 oxygen atom, but this is not the case. 2 to cancel out with each other. In other words, we know that magnesium has 2 electrons in its first shell. Sorry about that. 8 electrons in its second shell because its atomic number is 12, and 2 electrons in its valence shell, right? Whereas in case of oxygen, we have 2 electrons in its first shell and 6 electrons in its second shell. So it needs 2 electrons. It wants to lose 2 electrons. So these 2 electrons will be shifted from magnesium to oxygen, and we will be having magnesium plus 2 and oxygen minus 2. So for one magnesium, we need only one oxygen atom, right? So this is, for example, ionic compound. This is the same. The magnesium oxide has the formula of MgO. This is its molecular formula. This is its empirical formula as well. Is it clear? Although it is not a molecule, it is formula unit, right? It means its formula unit will contain one magnesium and one oxygen atom. Are we clear about that? Aliza, Ishal, Eza, Nabiha, is it clear?
Yes, sir.
All right.
Yes, sir.
So, all right, this one is clear. Now we have discussed about the formulas for organic molecules that were open or displayed structural formulas, simplified structural formulas, and molecular formulas, right? This is the reason. Ionic compound or inorganic compound is always an empirical formula. Now, should I recall the formulas for organic compounds or not?
Sir, कौन से
Organic compounds, the displayed structural formula, the simplified structural formulas, and molecular formulas. Should I recall, or you have gotten the clear concept? You remember that? Do you remember? Let me give you an example. What?
Yeah.
All right. So,
Sir,
yes,
explain.
please. For example, we have a compound, right? So, for example, this is an organic compound, and its name will be molecule having 6 carbon atoms will be called as
Xane.
hexane. Now, what is this portion?
CH3.
Yes, excellent. So, can we write over here CH3? And what about this one?
Two.
All right, we have written. And of course, what about this one and this one and this one? How many CH3 more?
3 CH2.
Yes, 3 CH2s, and then the terminal one, that is
C.
again
CS3.
CH3, right? At the terminal position, so you'll be writing CH3. Now, this one was displayed structural formula, right? And this one is simplified structural formula. In displayed structural formula, you represent each and every bond and each and every carbon atom and the connectivity, that's right. Whereas in simplified structure formula, you omit, you remove, you basically erase the bonds between carbon and hydrogen. You can also write a simplified structure formula like that, CH3, and how many common CH2 groups?
4.
4. So we will be writing CH2, 4, and then this one, right? CH3. This is a structure formula. What about molecular formula? Total number of carbons are 6, and total number of hydrogens are 14. This is a molecular formula. Is it clear?
Yes, sir.
Perfect. Now again, much better. Elements included in group 1 will have +1 charge because they have 1 electron in their valence shell, and they will lose 1 electron to gain stability. For example, we are talking about sodium. Sodium has 2 electrons in its first shell, 8 electrons in its second shell, and 1 electron in its third shell. So it will lose 1 electron to form +1 ion, right? Unipositive cation. Same is the case with group 2 elements. For example, we have magnesium. It has 2 electrons in its first shell, 8 electrons in its second shell, and 2 electrons in its third shell. So magnesium will lose 2 electrons to form di-positive cation, and it will be having +2 charge. Similarly, what about group 3 elements? For example, aluminum, it has 2 electrons in its first shell, 8 electrons in its second shell, and 3 electrons in its third shell. So it will lose 3 electrons to form tri-positive cation, right? In case of group 4 elements, like for example carbon, it generally do not make ionic bond, rather it share electrons, like if for example it has 2 electrons in its first shell and 4 electrons in its second shell, so it needs 4 electrons. So either carbon will make 4 single bonds to complete its octet, or it will make 1 double bond and 2 single bonds like in this case, or it can make, for example, 1 triple bond and 1 single bond. So ultimately, carbon is in group 4, so it will have 4 electrons in its valence shell. It needs 4 electrons to complete its octet. What about group 5 elements? For example, nitrogen. It has 2 electrons in its first shell, 8 electrons in its second shell. Oh, sorry, not 8 electrons. 2 electrons in its first shell and 5 electrons in its second shell. So in order to complete octet, it needs 3 electrons, right? So it will gain 3 electrons to form tri-negative cation. Group 6 elements, for example, we have oxygen. It has 2 electrons in its first shell, 6 electrons in its second shell. So it needs 2 electrons to complete its octet. It will be gaining 2 electrons to form, yes, O-2 ion. Are we good? Am I clear
Yes,
to
sir.
you? Is there any problem? Is there any confusion? You can let me know. You can ask. Am I going so faster, or is it the speed is okay because we are in revision phase? In case of transition elements, for example, copper, we will be using Roman numeral next to the name of the element. For example, if you are going to write F, for example, Cl2, iron chloride, then its name will be indicated like that, iron 2 chloride, which means over here in this molecule, iron is showing +2 oxidation state, right? Because the transition elements can show variable oxidation state. It can show +3 oxidation state as well. But in this molecule, it is showing +2 oxidation state. Same is the case with copper. For example, in case of a compound called, its name will be written like that, copper 2 chloride, which indicates copper is having +2 charge, or oxidation state of copper in copper chloride will be +2. Is it clear? Same is the case with chromium.
Yes, sir.
All right. Now, for example, inorganic compound, the normal elements, the representative elements like nitrogen and hydrogen, what about this case? We know that, let me zoom it for you. All right. We know that nitrogen is in group 5A. Its atomic number is 7. It has 2 electrons in its first shell and 5 electrons in its second shell. So we can say that it needs how many electrons to complete its octet?
3.
3 electrons, right? So we are going to make the bond of nitrogen with 3 hydrogen atoms. Now, this molecule is called as NH3, right? We can write it like that, N3, and having lone pair of electrons. But what if it attacks on electron deficient hydrogen ion? This is called proton. Hydrogen atom, when it loses one electron, it becomes proton, and its symbol is H positive. So what about when this lone pair of electron attacks on H positive ion? Remember, the deficiency of electron with this atom will be shifted on nitrogen like that. NH3, and now as it has made bond with hydrogen, so the positive charge will shift on nitrogen, right? I have told you in the class that, for example, in case of nitrogen, it can make 3 bonds. But if it is going to make more than 3 bonds, then it will be having positive charge. And if it is going to make bond less than 3, like in case of NH2, then it will have minus charge, right? Okay.
Okay.
So NH4, this ion is called molecular ion, and its name is ammonium ion or ammonium cation, whatever you say, because it has donated one lone pair of electron to this hydrogen. In most of the cases, one electron is shared by nitrogen and one electron is shared by hydrogen. One by nitrogen and one by hydrogen. But in this case, both these electrons are shared by nitrogen. These two electrons are of nitrogen. As the nitrogen is donating all of its electron, no, not all of its electron, as nitrogen is donating both of the electrons that is needed to make a bond between nitrogen and hydrogen. That's why it will be having positive charge, right? Is it clear? Any confusion?
Yes, sir.
Now,
Yes, sir.
in case of, for example, water, oxygen is in group 6A. It means it needs 2 electrons. So in case of water, it shares 2 electrons with hydrogen, right? But if we remove this hydrogen from water, then it will become like that. Oxygen, this bond was already made with hydrogen, and the electron of hydrogen remains with that of oxygen, right? We have removed H positive ion. In other words, the hydrogen atom without electron. This negative sign shows for removal, not for electron, right? We have removed H positive ion. We have removed just this proton from the water molecule. Let me zoom it for you more. We have just removed this hydrogen from water molecule, and the electron of this hydrogen is left with the oxygen. That's why oxygen in this case will be having minus charge, because it has extra electron with it. I have told you in the class that whenever oxygen is making 2 bonds, it will be neutral. Whenever it is making 3 bonds more than its normal bond, then it will be having positive charge. Whenever it is making less than 2 bonds, then it will be having minus charge. Same is the case with the already discussed example. in case of nitrogen. If it is making 3 bonds, it will be neutral. If it is making more than 3 bonds, then it will be having positive charge. And if it is making less than 3 bonds, then it will be having negative charge. Are we clear about that? Is there any confusion?
No, sir.
Alright. Same is the case with all these anions, right? Just practice it at your home. This is your home task, and then let me know if you get any confusion while solving these. Just you will have to, for example, understand the concept that why NO3 has -1 charge, why it has -2 charge, why carbonate has -2 charge, why bicarbonate has, or in other words, hydrogen carbonate has -1 charge. Is it clear?
Yes, sir.
Next question is that I've told you that if nitrogen is making 3 bonds with hydrogen, then it will be neutral. Why it will be neutral? Let me show you. H3. The valency of nitrogen is -3. We know the valency of hydrogen is +1. So there are 3 hydrogen atoms. So that will be +3. So +3 and -3 cancel out each other. That's why this is neutral molecule. Same is the case with water. Its valency is +1. There are 2 hydrogen atoms. So the total will be +2 and oxygen is -2. So -2 and +2 cancel out each other and this compound will be neutral. The sum of the charges will equal to 0. While in this case, look at here, for example, NH4. The valency of nitrogen is -3. The valency of hydrogen is +1. There are 4 hydrogen atoms, so the total will be 4. Now, this molecule is not balanced, not neutral, right? +4 and -3 equals +1. That's why we are writing +1 charge on ammonium ion. In this case, the OH negative ion case, oxygen is having -2 oxidation state, whereas hydrogen is having +1 oxidation state. It is only one, right? So +2 and -2 never cancel out each other, and the resultant answer will be -1. Clear? Is it clear?
Yes. Yes.
H3O. If you look at this example, the oxidation state of oxygen is -2 and oxidation state of hydrogen is +1. There are 3 hydrogen atoms, so +3 and -2 will become +1. That's why we write +1 on H3O. Are we good?
Yes, sir.
Perfect. So if more than one, for example, this one is anion, this one is cation, this will be having positive charge, this will be having negative charge. If cation or anion is having more than one atom, right, then we will be using bracket. Like for example, magnesium, right, we are going to react it with OH. Now this is the negatively charged portion, this is the positively charged portion. Now look at its oxidation state. The valency of magnesium is +2 or oxidation is +2, and oxygen overall -1, -2 and +1, so it becomes -1. So again by cross multiplication rule, we will be having magnesium 1, no need to write 1, and hydroxide as 2. It's clear? Now another example, another way of doing that. For example, magnesium hydroxide. The charge on OH is -1, we know that. Alright, and there are 2 hydroxide ion, so the total charge will be -2. Magnesium is +2, so -2 and +2 cancel out each other. That's why we will always be writing OH whole twice. Is it clear?
Yes.
What is the formula of sodium bromide? Just solve it, please. You will have to tell me. Sodium bromide. Hurry up. There are, I think, 5 girls in this class. I will be asking one from each. Isa, first of all, from you. What is the formula of sodium bromide?
NABR.
NABR. Why? Because Na and then Br, Na is +1, Br is -1 because it is in group 7A. It will gain 1 electron to form -1 ion, so cross multiplication rule and so on. In other words, Na and Br -1 +1 cancel out each other. Nabiha, aluminum fluoride. The next one.
FL ALF whole क्या था
AL
ट्राइस F फ्लोराइड का सर फ्लोराइड का FL है
just F. The symbol of fluorine is F.
oh yes sir ALFL sorry whole thrice
Whole, no, just 3. Left 3, right? You will be using whole when there are two atoms combined together. In this case, oh, I'm sorry about that. Like for example, in this case, so
Yes.
Al and F, Al and F, again cross multiplication. So AlF3, right? Again, Alize.
Aluminium oxide का
Yes, please.
Al2O3.
Al2O3. Let me check. Ishal, magnesium nitrate. Are you here with us, Ishal?
MgNO3 whole twice.
Shabash. MgNO3 whole twice. Why? Let me show you over here. For example, NO3. Oxygen is -2, right? Forget about that. Valence of oxygen, we are going to check the charge on NO3, right? Because this is nitrate. So the valency of oxygen is -2, as there are 3 oxygen atoms, so the total will become -6. And also over here, nitrogen will be showing +5 because oxygen is much more higher electronegative than nitrogen, and there are of course 3 oxygen atoms, so this becomes more powerful for nitrogen. So that's 5 electrons of nitrogen little bit pushes away from the nitrogen. So over here nitrogen will be showing +5. Nitrogen is in group 5a. It means it has 2 electrons in its first shell, it has 5 electrons in its second shell, so it needs 3 electrons. It generally accepts 3 electrons and have -3 charge, but if it is attached with high electronegative atom like oxygen, then it will tend to lose a little bit of all these 5 electrons, right? In other words, the 3 oxygen atoms will attract the 5 electrons from nitrogen, making the nitrogen +5. So -5, oh sorry, +5 and -6 becomes -1, right? So that's why NO3 will be having -1 charge. And magnesium, we know that magnesium is in group 2, right? So magnesium will be having +2 charge, and we have calculated NO3 as -1. So again, cross multiplication rule, Mg is having only 1 and NO3 will be having 2. Is it clear? So magnesium nitrate. Okay, now ammonium sulfate. Who will tell me about the ammonium sulfate? Let me divide this question into two. Nabiha, are you
जी
here with
सर.
us? You and Iza will combine together to answer this question. First of all, Nabiha, tell me, what should be the total charge on sulfate ion?
Sir 2.
Wait. For example, sulfate, the formula of sulfate is SO4.
So
Now, can
4
you
minus
tell
3.
me what should be the overall charge on this ion?
3 4s are 12. So minus 12 होगा ऊपर.
What? Speak
Sir
is
minus 3 है.
your speaker is bouncing back. I'm hearing my voice from your mic. No, 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 no. Nabiha, you can
सर
calculate,
सल्फर
right?
का minus 2 नहीं होता.
Wait. The oxygen is having -2 charge. Are you agree with me? Do you agree with me?
Yes.
One oxygen is having -2, so the 4 oxygen will be having
Minus 8.
8. What about sulfur? Sulfur is in group 6th, right? It means it has 2 electrons in its first shell, 8 electrons in its second shell, and 6 electrons in its third shell. What will it do? Tables become
Minus 2.
-2, right? So we know that oxygen is high electronegative as compared to sulfur, and also oxygen is having minus charge, so we cannot write -2 again on the sulfur. So what is the next possibility? Like in case of nitrogen, it is having 5 electrons in its valence shell, so one possibility was that it will gain 3 electrons to form -3 ion, or the next possibility was that it will lose all 5 electrons to form +5 ion, right? So one possibility for sulfur is gaining 2 electrons to form -2 ion. What is the next possibility?
Losing all 6
Yeah,
electrons.
so it will be having which charge?
Plus 6.
Excellent. +6. Now calculate it. What should be the overall charge?
Minus 2.
Excellent. Bus. So SO4 is having -2 charge. Now, Eza, क्या था?
जी सर।
Ammonium. What is the charge on ammonium? The formula of ammonium is NH4. What should be its charge and why? Is are here with us?
सर पता नहीं।
Mhm. अभी मैंने बताया था ना?
सर +4
Yes, Isa. Recall this again, please.
+1
And 4 hydrogen will be having,
+4
and nitrogen is having.
-3
So the total will become.
+1.
Yes, this is it. This is it, right? So we can say that NH4 is having +1. So once again, 1 and this is 2. So cross multiplication rule. Is it okay? So we will be writing NH4 whole twice and then sulfate. Any question, any confusion, any problem, any query, you can let me know.
No sir.
Is it clear to you? Everybody?
Yes sir. Yes sir.
Say Alhamdulillah.
Alhamdulillah.
NABR, ALF3, Al2O3, MgNO3, and NH4 whole twice, SO4. Now then writing the equation, but one is called as word equation, right? Much better that you'll have to write the name of reactant. For example, sodium hydroxide is going to react with hydrochloric acid, which produces or tends to produce or goes or equal to or will react together to produce sodium chloride and water. Clear? So this is called as reaction arrow. The left side of reaction arrow shows the reactants, whereas right side of the reaction shows the products. So these are the products formed, and these were reactants that were reacting together. Is it clear? And there is no need to write the symbol because it is word equation. So when you are asked to write word equation, you should not write like that. NaOH reacts with HCl to form NaCl plus water. This one will be wrong because this is word equation. Clear? Full chemical name. Okay, name of compound, we will be discussing this from next week, inshallah. All right, okay,
Yes, sir.
wait. Hmm.